All right, welcome everyone to this webinar on the new face engine that we call FaceCore. Let's get started. There might be a few more of you that will drop in, but I think we'll dive right into it. So FaceCore was recently released as part of maybe a major part of the 2.0 version of the Furhat Platform that we released 3 weeks back. We're super excited about this update, and we think it's going to be really important for getting people and our customers to really make the most use out of the Furhat Robot and have these really engaging social interactions. The plan for today is I have brought with me Jonas Beskow, co-founder of Furhat Robotics, and our senior engineer that has been heavily involved with creating this new FaceCore system. I will give the word over to Jonas in just a bit, and he will tell you all about it. But I would also like to mention that in the end, we will get to meet Furhat. I always try to bring Furhat in at some point in these webinars. And we'll get a little performance from Furhat. So please stick around until the end, because I think that will be a little bit fun. This is part of a series of webinars. We have done a couple of webinars before on the different parts of the robot. So if you're interested to dive deeper into other areas of the robot, you can check them out on our YouTube channel. Great. Without further ado, I would like to hand it over to Jonas. Please take it away.
Okay, so we're going to talk about the face today. I mean, since you're tuned in, I think you're all familiar with the Furhat Robot as what it is in principle. I mean, it sets itself apart from most other robots, basically through its face, among other things. I mean, there are other unique aspects, but the focus today will be on the face. And you could say that there are really 2 things about the face that makes Furhat different. One of them is that it can change appearance completely. As you know, you can project different things onto the mask, and you can also change the mask. So you can really have a very big span of possible characters that this robot can embody. So that's sort of the static aspect of it, if you will. You can change it to become a different character, but then there's also the dynamic aspect. You can perform different gestures, and you have much more degrees of freedom than you would have on a robot with a typical robot with a mechanical face. So there are many things that you can do because it's animated, because it's projected. There are many things that you can do that would be impossible with a more traditional or mechatronic robot. So that's really the starting point of all this that we're going to dig deeper into today. And these 2 aspects, the possibility to change character and to expressively animate the face. And this is where we have exciting news in this update with FaceCore. But first, before we do that, let's take a few steps back where we look at some of the characters that has been sort of built on the Furhat platform. This might not be common knowledge, but we have this. Well, many years ago, when we just started the company, people came to us and said, "Can you do this and this?" I mean, people had different suggestions, basically, on characters that they wanted to see on the robot, and one of these was to build a clone of a Swedish politician to take part in a debate and so on. So this was quite a fun project, and we had even the hairdo custom designed and 3D printed. So it's a little bit of a caricature, as you can see, but I think that's sort of a form that works quite nicely. And then we took that aspect even further in 2019, when a Japanese gaming company approached us and asked if we could make one of their cartoon or anime characters into robots. So we of course we couldn't resist doing that, and I think we were quite excited about it and quite happy with the results. There's a quick shot. So you see, you can really also use the projected face to express things that are not, to go beyond the realism and to go into, for example, in this case, the traditional manga style animations, and so on. So all of these are things are possible, and of course, why stay in the sort of human realm? We can also do animals, the pug. So here we use the custom mask and the custom underlying model also. Okay, so these are all these all show you sort of the range a bit of what is possible to do, but of course there are limitations in how accessible these features are. So this has been one thing. All of these examples that I've shown you took a substantial amount of work. People work with sort of specialized tools and complicated tool chains to achieve this. So one of the things that we wanted to achieve when doing a sort of an overhaul of the face engine in Furhat was to somehow lower the bar a bit for this kind of modifications. So what you could do basically on your own with the previous face engine was that you could change textures. You could download the textures from the robot and you can modify them, for example, in Photoshop, and you can upload them again. And it offers some customization, but still fairly limited, and also quite difficult to know what you will, what the effects will be. So not ideal. So we wanted really to improve that experience, and maybe if it does, and give users more control, basically, in how the characters look and appear on the robot. So that was one thing, and the other thing was that we wanted to increase the expressivity. So what is FaceCore? Well, it's an all-new face engine. So the software that runs on the robot to animate the face, that's the face engine of the robot, and it was designed from ground up for customizability and expressiveness in mind. So we'll go back to what that means in a bit. It was built also with industry standard tools. Well, why is this important? Well, it means that at some level, the underlying models are built in a way that can be improved upon and adapted upon by people who know these tools. And although they're not sort of exposed through the system, it's still a possibility for the future that we can open this up also and let people go completely custom on that level. So that's why it's good to mention it. But the features, to summarize, basically, so we have increased visual fidelity. If you compare it to the old model, you will see quite substantial improvement, for example, around the eyes and how shadows fall. For example, we have a simulation of the real lighting effects of the room in a way, so you can have shadows that move as the robot moves its head, for example, as if it was lit by a real light, although it's in the virtual model. And importantly, FaceCore runs both on the robot and in the virtual Furhat simulator. So if you've used the Furhat SDK, you know that the virtual Furhat is a simulation of the real robot. There used to be, it's been there for a long time, but the correspondence between what you actually see on the robot and what you see in the virtual Furhat hasn't been perfect, because there are two different face engines that have been sort of running in the robot and the virtual Furhat, whereas now these are completely in sync, so it's really the same thing running in the virtual Furhat also. So what we add now is something called character parameters, and this is really what aims towards the customizability. So you have a set of parameters that affect the shape and the appearance of the character. And then we also have new animation parameters that go towards the expressiveness. So these are two new classes of parameters. The animation parameters is what we've had all the while, but we have extended this in a way that I will talk about. And we have an exciting new option then to drive the animation, the face and the head motion from captured motion. So real human face motion. Okay, so let's start with the virtual Furhat. As I said, it's a much more of a high fidelity replica now of the real robot. So here you see them so side by side performing some expressions and gestures, and yes, they are quite well in sync. And as you perhaps know, then the virtual Furhat is part of the Furhat SDK that you download from furhat.io, and it runs on major platforms that you would expect. Okay, so let's look at the character parameters. What are these and how can they be used? Okay, so there are essentially two classes of character parameters. So character parameters are essentially what you can use to modify the character. So you can think of this in terms, for example, if you've in some video games, for example, you have the ability to build your own avatar. You can drag and modify certain sliders and so on to change the different elements of the face. This is in a similar way to what we're doing here, and it consists of two parts. We have the texture overlays that are essentially a way to compose the skin of the character through different layers. So while before you had to like I said, download the texture in and put it into Photoshop and do some editing there, but now you can do in a way the editing directly on the robot, in the sense that you can combine, for example, a new set of eyebrows and an eye texture and eyelashes and so on, and lips and so on. And you can also adjust the colors individually of all these elements. So suppose that we start with a sort of featureless face, then we can add different kinds of eyebrows to it, different kinds of facial hair, different sort of lip colors and so on. So this is all available sort of in the engine, and is possible. Right. Well, yeah. So I'll come back to how to access these things, but then we also have another set of parameters that deform and shape the different features of the face. So you can essentially adjust position, size, and shape of the different elements in the face, the nose and the lips and so on. Now, of course, this can be done, but only to a certain extent, because we're still limited by the fact that we're projecting everything onto a mask. So you have to take a little bit care that you're still matching, for example, the position of the nose. If you move it, at least if you move too much, it will not look good. But you will still have these options, and some other features like the mouth is more free to move because it's a fairly smooth area, at least on the standard mask. So you can really do all sorts of interesting effects with this, also cartoon and character faces, and keep you the flexibility. And actually, so in relation to the mask, topic, you can really use this also to build to take an existing model and map it onto a different mask. So this used to be a problem in the old, or it used to be a limitation, I should say, of the old system, that a new mask required a new model. There wasn't a way to just take a new mask and adapt an old model. But now you can really do this. Now you can take different masks, and you can basically move around the eyes and the nose so that it fits, and then you're good to go, and you can tweak the appearance in a way. So it's more flexible in that sense. And now I'd like to switch into a little quick demo. So now I'm in the Python prompt here. So let's do some Python. So I will say from Furhat Remote API, import Furhat API, like this. And then I will say Furhat equals Furhat Remote API local host. So what I'm doing now is that I'm establishing a connection to the Furhat system running on my local computer. Now I could type the IP address of a robot here. If that robot has the Furhat Remote API running, then I would control the robot. Okay. And then I'm gonna add a little bit of helper code that I'm now pasting in. It's a function essentially that allows me to set a parameter. And what this function, we can go into the details what this function does later, but now let me just show you. So I say set par eyes scale up 1.5. So as you can see now, the eyes just got bigger. I can say mouth down. Mouth moves down. And of course, we can still.
Hello, I am a speaking robot.
So yeah, so this is one way of accessing these parameters. And so let's go back and look at this this little helper function that I pasted in. What it's doing is simply to perform a gesture that is actually defined in line in real time. So what you're saying is, hey, Furhat, perform this gesture, and then you say definition equals, and you give it a little bit of JSON or a dictionary here that specifies the animation targets. So we're just saying that at time 0.05, we want a certain parameter to get a certain value, and this is actually what we feed in as the argument here. So we can, so that's really a simple way of just setting a parameter through the remote API. And you can, of course, use exactly the same type of definition to perform a more complex gesture. If you wanted to raise its eyebrows and then go down, you can just add another time frame target where it's also going back down. Right, so that's a quick view on how you can use it. And of course, you can do the same thing within Kotlin from a skill, but I just like to show this remote API because I find it easy to use and a nice way of controlling Furhat. Now it's yeah. So this is basically what this way of controlling the parameters is what is available right now if you want to play with this. But we should also say that we have plans and sort of in the some things are cooking. it goes under the name of character creation tool. And the idea with the character creation tool is that you should be able to, here really, as the name implies, you should be able to create your characters by dragging sliders and setting these overlays that I described, and then save everything as one character. And then you can go back and upload that to a robot, or you can use it in your virtual Furhat and so on. So this eventually will be the go-to way of designing characters. But yeah, you'd have to be a little bit patient for it. But right now you can, as I said, you can already play with this through the APIs, and you can also use the pre-made characters. I can show you what they look like. So Furhat already comes with a number of characters designed using this this system. So I can switch around here, and maybe you can do this directly. Maybe you tried it if you downloaded the latest SDK. So we have a number of new characters here, Chen, for example. And actually, when I switch now, you can see that it's building up layer by layer. And this is actually what I've talked about, these different overlays. They're getting applied step by step. So you can actually see how it's building up the face. So here's another. It's changing the shape, and then it's changing the texture step by step. Anyway, we're going through this quickly. Maybe look at one of the less human examples here. We have this robot character. All right, moving on. Let's look at the animation parameters. So we talk now about the first part, which is really how you can create new characters and have much more flexibility in that process. And now we're going to look at the expressiveness. How can you really improve? What does FaceCore add to improve the expressiveness? So the Furhat face is driven by blend shapes. So blend shapes is a general computer graphics term for how you deform a graphics object by sort of blending between shapes with the same topology. So it's really, and you can have any number of these, and you can combine them also in any way by setting different weights. So this is the basis for the Furhat animation as it always has been. And we can divide this now into different classes. So we have the Furhat standard set of 46 blend shapes that has always been available on the robot, that you can do to perform gestures and to animate speech and so on. And these are still there. So it's backwards compatible in that way. So if you have gestures, don't mind the robot going haywire here. It's just flipping through all the blend shapes one by one to see what they look like in their extremes. And then in addition, you also have animatable character parameters. So the things I just showed you, when the eyes get bigger and the mouth moves up and down, for example, these are actually animatable also. So they're not only for making new characters, but you can also use them in animation, which is then useful if you want to go beyond the realistic, if you want to go into cartoon territories. So you can, for example, have a gesture that where the eyes bulge and pop, and so on. So that can be experimented with for lots of fun. But then we come to the last category, which is the Apple ARKit, which is really the most interesting novelty here, I would want to say. So what is Apple ARKit? Well, this is something that was introduced when Apple released the iPhone X. And they also they added a lot of technology in that phone that is now present in all new Apple iPhones. And most interestingly, it had this thing they call the depth, the true depth camera. which is essentially a little projector that sends out a pattern that is then captured by an infrared camera. And this is the same technique that was developed for the Microsoft Kinect, the sensors. And they also added a lot of software. They acquired a company from Switzerland called FaceShift that was specializing at that time in using the Kinect to do facial capture and high fidelity sort of motion capture of faces and transferring this onto models. So they bought their whole technology stack and put that into Apple, into iOS. So really what you can do with this now is that you can use this camera to track the face with quite high accuracy. And what you get is 52 blend shapes. So it's not only tracking a mesh like many other technologies can do, but you really get parameters that you can then use to animate the face. So you have 52 blend shapes that are similar to the facial action coding system. So you can often translate this one by one if you're familiar with that standard. And there are online websites that describe the correspondence between these. So some examples of these 52, what they look like. So you have things like jaw open, which is a quite straightforward one, but you also have very subtle gestures like cheek squint, which is sort of when you move this little area of the cheek up to make a slight squint. You can barely see it on these prototypical blend shapes, but it's a very real effect. And I actually want to show you the in the same way that we did before with let me just switch to another face here. Let's go with James. So in the same vein here, we can, let's see if I can use so jaw open. Oops. Maybe to 0.5 like this. And let's try the cheek squint. Squint. Right. 1.0. So yeah, if you can see on this side, it's doing a little squint. So these are sort of subtle but very useful and very powerful parameters. However, just being able to control them through the API is not the most interesting part. Of course, it is that you can really do motion capture using you can directly record and track this from the camera. So now I'm gonna bring in hopefully a view of my iPhone that I have here. So there's my face. Now I'm running an app called LiveLink Face. It was developed by Epic Games. It's in the App Store. And this is what we're using now to so it basically lets you record all of these. I should say that the ARKit is sort of it's an SDK, which means that you can build your own apps. If you know how to build an iPhone app, you can actually use it and build your own app. So people have done many of these. If you search on the App Store, but also in terms of open source, if you know how to sort of compile and build an app for an iPhone, it's not trivial, but it's possible. Anyway, this one is a good. You can, I don't know, this text is very small now, I think, but you can actually see in this overlay updating in real time the value of all of these 52 blend shapes. So for example, here is this jaw open. If you look here, I don't know, maybe you can't see that. but it's fun to play with, and you can then record. So if I do something like this now, press record here. Hi there, do you like robots? Okay, sorry, that didn't work. Let's try again. I'm pressing record. Hi there, do you like robots? Okay, so now I did a little recording, and I have actually now, as a TV chef, prepared and sort of pre-cooked this. But what you do with this recording now, I can show you, is that you can scroll through a list of all your recordings, and we look at Thursday, 16th of September, and we have this. We have this recording as a video, but it also captures the, of course, the facial movements, and you get that in the form of a CSV file. So what you can do here is that you can use AirDrop to simply send it to your computer, and so I'm receiving now a zip file that includes both the video and the data, the face parameter data. And I can then use that with a little tool that is also available to download from our from Furhat's website, where you can convert this into a gesture. But to save you, to spare you all of those steps, I've sort of pre-cooked some examples. And one thing that you can do with this tool is that you can actually, you can actually select what parts of the motion to export also. So it takes in the CSV file, and then you can choose if you want the eyes, mouth, head movements, lip movements, and so on. And then you can export everything in the JSON format that you can then put into your skill or use through the remote API. And now I actually have a skill that was built in this way, and then I can, so now I will just play back the motions. Let me just reset the character, put it to Marty, and now if I look at only the eye movements that was recorded, and it looks like this. And now we can look at the slowed down version of the eyes, including the eyebrows. So we add the eyebrows and we slow everything down by 0.4. This is also a feature of the conversion tool that you can set the rate. So you see that it's let me, okay, and then we can add also the head movements. It looks like this, back at full speed. And now we can play it back, including the audio and lip movements.
Hi there, do you like robots?
Okay, so basically this is a very flexible and convenient way to quickly create both gestures, spoken prompts, and also entire performances, as you will see also at the very end now. But this is what we can do. Yeah, so I said that it captures blend shapes, eye gaze. It's, as you saw, it's surprisingly good as a gaze tracker, even the iPhone. So you get head rotation and you get audio. So that's everything you need to make a sort of complete Furhat complete Furhat expressions and performances. And you have the video as a reference. Okay, that is it for my walkthrough of FaceCore, and now I think I will hand back to Nils.
Yes, super. Thanks, Jonas. That was a great in-depth explanation for FaceCore, but also a little bit sort of bigger perspective on the face on the robot. Super. I think that will be very helpful for all the people to understand what is FaceCore and what is actually new here that we've released. In the beginning, the one thing I forgot to mention, if you have any questions for Jonas or for me, you can please just write them in the Q&A section. I see some people have already written them there. You will have some extra time to write a question because in the beginning there I promised that we will get a little interaction with the physical Furhat as well. Furhat has patiently been waiting here in the room next to me. So I will kick him off and then we'll take your questions.
I've just seen a face I can't forget.
All right, super. Thank you, Furhat. So that was a good example of what you can do with this motion capture feature that we used to list. And I think it's really fun. And I can't help to sort of want to sing along with Furhat. I hope you had a good experience seeing the robot. It's kind of difficult to show it over video like this. The internet connection and timing with lip movements and lip syncing might throw it off a little bit with the sound and the video, but hopefully it looked good for you. So let's jump right into the questions. So I have first a question here. Can we still use the old process of modifying face and use that face with the new FaceCore?
It's a bit unclear what it means, but the old process, I'm assuming that it's about editing the textures offline, for example, in Photoshop. Yeah, so this is still I think this will still be possible right now. we still don't have the sort of the asset import functionality all the way in the web interface like we have for the old faces, where you can upload textures through the web interface. But the idea is that this whole layering idea will also be accessible. So one way of using that is just to have you have some base texture and then you add different facial features on top of it, but you don't have to do that. You can just have the base texture and then it will work just as before. That being said, once we have the ability to import these gestures to the web interface, yes. Otherwise, if you're using the virtual Furhat, there are ways to sort of find the right folder in the distribution, but sort of hacky ways of finding where the actual texture files are located and change them there. But this is certainly the idea, that you could still use the same principle. Although, if you have made changes to the old faces, sort of custom textures for the old faces, they won't be available in FaceCore because it's a completely different animation system. So it won't sort of read the old formats or the old ways of specifying textures.
Yeah, and like Jonas said there, currently customizing the face is still an internal process that we do, and we are still working on how we're going to expose it to the developer themselves to be able to access these parameters and to access this overlay system to actually really create their faces and upload them and switch them from the virtual robot to the physical robot and all of the things that are necessary to have this feature. Another question that you have here is, would it be possible for the robot to get the input from the iPhone camera in real time during the interaction, so that you could have like a telepresence functionality with the robot?
Nice. Yeah, this is certainly something that we have, of course, thought about, and we have done. We have played with this internally also. The main limitation right now is that we don't have. I mean, essentially, it requires an app on the iPhone that will stream the parameters in real time. And the one that we're using now, the LiveLink Face, it's convenient because it's in the App Store. It does in fact stream parameters, but only to only to Unreal Engine, which is sort of Epic Games. So they have their own protocol for that. But ARKit is an SDK that allows you to build your own apps, and people have built these kinds of apps. So the main limitation is actually how to get. If you're willing to put in some coding and to do some legwork yourself, you can actually do it today. But that being said, of course, we understand that this might not be something that most people are prepared to go into. So we are thinking about ways to do a full telepresence solution with an app that will capture your face and also your voice then. So you should capture everything and stream that to the robot. This is not in place, but we're certainly thinking about how to accomplish something like that. I think it can be potentially very useful for different kinds of scenarios.
Yeah. And a follow-up question there personally from me, because the telepresence use case, I mean, that's one way of making use of that information from the camera. But I remember you talking about you could also use this for having the robot sort of mimic the person that is talking to. And I think you had an example where if you have a 5-second delay, or I don't know how much the delay was, you can. It can be a pretty interesting and powerful experience of having the robot mimic you.
Yes, definitely. I think this whole tool chain is an enabler for lots of interesting research, and this is actually something that we're working on at my lab at KTH, where I'm a professor, where we're trying to also to use algorithms that sort of machine learning based models that will produce appropriate gestures based on the gestures that the user is performing. So this is in a way to mimic and to adapt.
Yeah.
So yeah, it can certainly be used for that. Yeah.
That's so interesting and so cool. So it's going to be great to see the work coming out, not only from Furhat Robotics but also then from KTH, like Jonas said, that is who's professor there. Great. We have time for a couple more questions. Let's pick one here. Can I get my own face on the robot? I think I've heard that question before.
Right. Yeah. It's a good question. I mean, we've chosen not to include a sort of off-the-shelf way of doing this, because we know that often the results are, it requires a lot of manual work and a lot of skilled work together. The fully automatic ways are usually not that useful. But what you can do, or this is at least our ambition with the character params, that you should be able to get quite close. You can get the right proportions by moving, for example, selecting different eye shapes and different mouth shapes and so on to match your own face. This is very similar to what many other platforms are doing. So for example, if you go into the iPhone, you have this little way of creating your own Animoji, which is sort of a cartoonized version of yourself. And it's the same thing there. It's not based on a photo, but it's based on you yourself actually selecting, this kind of eyebrows, this kind of eyes. And yeah, it's a bit of it's a bit of a trial and error, but sometimes you can get quite close, so people can actually tell you tell who it is, and you get quite good resemblance. But so this is sort of what you can do out of the box. Otherwise, you would have to use more advanced tools and then make a model that can be imported. But this is not sort of so easy to do.
Yep. I have one more question here. I think we have time for one more question. So why did you decide to use the ARKit from Apple? Will there be support for this motion capture or Android or other platforms? It's the platform war question.
Right. Yeah, that's a very good question. We're not taking sides in any kind of platform war. That's important to point out. So the main reason that we're using Apple ARKit is because it's a really unique technology right now in the market, and a lot of this kind of techniques for doing motion capture on faces is what used to be sort of $10,000 software that was very specialized, used for animators and game studios. And the fact is that many game studios and people in the business are using the iPhone now more and more for in motion capture labs and so on. So you actually use it in combination with motion capture suits and so on. You put the iPhone on a helmet and so on. So it's really a technology that is being used, and there is not anything that is comparable on Android. There are other techniques for tracking faces, of course. You can get a face mesh, but the unique thing with the iPhone is that you actually get these parameters that lets you then animate a model that works independently of who the person is that you're filming. Otherwise, you always have a problem with the person dependency in the recordings, so it won't sort of map onto another character. So that's basically why we're using Apple. But we're also looking into other sort of platform independent technologies. It would be great to be able to do this from a video recording, for example. This can't be done now. You have to have the physical phone in front of your face. So this is the limitation, and it would we're looking at possible solutions, but we can't really say anything right now if it's going to be possible.
Super, thanks, Jonas. Thank you for your time and for giving this great presentation. I think we will cut it short there, so people have 5 minutes to go to the next meeting or or go home. Maybe it's the end of the day here. Super. Thanks you everyone for joining. This webinar will be available on YouTube later in a couple of days if you want to share it with a friend or colleague, where we also have other episodes for other aspects of the robot. Please, if you want to follow us, you can sign up for a newsletter on our website or on our social media channels to get more updates on things that's going on Furhat, both on the technology, but also on the business or on other aspects of the company and the robot. Great. Thank you all for joining, and don't forget to smile. Ciao.
Thank you. Bye.